Okay, so recipe to make 12 scones. How much self-raising flour will Gustav need to make 30 scones? Okay, so self-raising flour we're talking here. There's a couple of ways of doing this. If it's 450 grams, we'll make 12 scones. We can work out I suppose, how many grams you need for one scone. Yeah, you do it that way. So you could scale it down, yeah. If you think about it, that's got to be shared amongst 12 scones. So if we share that by 12, we can see what one scone would be worth. We get 37.5 grams. Okay, for one scone, and then to get 30 scones, okay, of course you just need to times that by 30. So 37.5 times 30, okay, will be 1125 grams for 30 scones, okay, which I believe is there, 1125 here, okay. The other way of it is appreciating that 12 goes into 30 2.5 times, because if you double 12 you get 24, and then there's 6 left over, and 6 is half of 12, so it's 2.5. So if you times 450 by 2.5, you get the same answer out, okay. Part 2 then says, in the recipe the temperature of the oven is given in degrees Fahrenheit. Temperature gauge then on Gustav's oven shows degrees Celsius, so we need a formula, don't we, to convert, right? So you can see here in the recipe here 428 degrees Fahrenheit, and we need to work it out what it is in Celsius, because that's what his oven works in. So we just use this formula. So Celsius will be 5F, right? So 5. Now when you see 5F, that means 5 times F, yeah? So be timesing F. Now F in this case is 428 degrees Fahrenheit, and this is minus 160, and it's all divided by 9. Now if you're confident, you can do all this in one go using the calculator. Okay, fraction button. Okay, so if you use the fraction button, you can do it all in one go. 5 times 428, take away 160, arrow down, all over 9, and press equals, and we get 220 degrees Celsius. Okay. So part B then says, Gustav also makes a birthday cake for his sister, and the top is in the shape of a trapezium. Okay, so he plans to ice the top face of the cake, and then each packet of icing costs £1.35 and enough to cover 65 centimeters squared. Okay, he has to buy complete packets of icing. Alright, let's calculate the area of the top face. We've got to calculate the area here. Now, this is a trapezium, and trapezium formula is given to us on page 2 in the formula list. Okay, so you don't need to remember it. This particular one is there. Half a plus b times h. And the a and b are the two sides that are parallel. Okay, so you can call that a if you want, that b doesn't matter. And the h is the perpendicular height, okay, between them, right? So you need that height there, which is perpendicular to both a and b. Okay, so the height ultimately is always perpendicular to the ground. So we put those values in. Half 20 plus 15, that's what a and b is, and then h, so times h, which is 12, and we get our answer out. So use my calculator. 1/2 bracket 20 plus 15 close bracket times 12, and we get our 210 centimeters squared. Okay, how much will it cost Gustav to ice the top of the cake? Now remember, it says here that he's got enough to cover 65 centimeters squared. Okay, that's what one packet, okay, one packet covers 65 centimeters squared. So we need to see how many 65s are in here ultimately. So what we'll do is just divide 210 divide by 65, and we get 3.23, right? So he needs 3.23 packets. Now of course you can't buy 3.23 packets. He says he's got to buy complete packets, so you need to buy 4 packets. And of course then 4 packets will be 4 lots of £1.35, It's saying how much does it cost, and we get 5.4, so £5.40. Okay, part 3 then, it says Gustav also plans to decorate the cake with small pieces of marzipan shaped as shown below. The top face of each marzipan is a rhombus. Will these pieces of marzipan tessellate? Draw a simple diagram to support your answer. Well, the answer is yes. Will it tessellate? Well, let me draw some rhombuses, okay, to show that they tessellate. So if we've got rhombus, okay, not easy to draw. Tessellate means that you can tile them essentially with no gaps, right? So I've got a rhombus there. Maybe draw another rhombus now. Here. It's more like a kite that I'm drawing, but don't worry too much. Okay, I'm just going to show that they tessellate. Okay, so yeah, it's not particularly great, but what I can do then is put one here. So if I was tiling, you could see then there's no gaps, and they meet at the point there with literally no gaps. Now we could fill in, we could put another rhombus here, couldn't we? Okay, so they're all rhombuses, and you could just keep going like that. Not particularly great diagram, but it's fine. It shows that there are no gaps, and you could keep going, and you could tile. Okay, that's showing that they tessellate.